I started making this video just to show the machining of this little screw that I've made here. Here it is right here. Well, you can't hardly see it. I'll show a picture. This little screw that I've made for this grip thing that I've made for my Canon G7X camera to hold a microphone in the camera and everything. And I was just going to show the machining part of it, you know, the machining on the lathe and the mill, but I don't feel like that really, I mean, it's kind of like, a lot of people like to see just machining, but it doesn't really show you anything about how to do machining or how to set up machine or a program or anything. So I feel like that's kind of, to me, it's kind of, I don't know, you let me know. I think it's kind of a waste for me just to show machining, but then I've seen so much machining over the years that it doesn't really do anything for me just to see the machine run. But some people like that, I guess. But I changed my mind. I edited the video and everything, and it was all right. But I don't like just to show something without showing something about how to do it or instructive type of information. So I kind of changed my mind. I'm gonna redo the video on this little screw, and it might be more than one episode because what I want to show, I don't like to make videos too long, maybe 10 or 15 minutes at most. It takes a long time to upload them, and you know, it just loses people's attention, I think, if you make too long of videos. So I might break this up into maybe I can do it in 2 10 or 15 minute videos. I'm gonna try that, and we'll see what happens. So let me get to the I'm gonna show a little computer stuff. That's kind of boring, I know, you know, and to me it's boring to even do it, but it's necessary nowadays with these modern machines. And then I'll show some clips of the machining, and you know, if you don't want to see the computer stuff, I guess you could kind of scroll forward in the video and not watch that if machining itself is just interesting to you. So let me get to it, and we'll show you about this little screw. Thanks. Here's a drawing of the part that I made on the computer to get dimensions to program the lathe to, and also to measure the part to see what dimensions the part need to be cut to. Okay, this is the my editor. I use a Predator CNC editor at the shop to transfer programs to and from the machine, and I saved this program from the Haas mill to the editor so I could explain it here on the computer. Normally I enter the program manually on the lathe because usually the programs are very simple, or the things I do on this lathe anyway are very simple. If it was very complex, I would do it in the CAM software, but in this case I just entered it on the control, so I had to save it to the computer in order to explain it here. I increased the font size on the display here so that we could see it easier on the screen. I'm just going to go through the program here and explain what the commands are in the program for those that maybe don't know this stuff. So this line here is just calling up tool 2, and MO6 is a tool change. You technically don't need this on this little Haas mill because every time you call a new tool, it'll stop, because this is kind of a manual CNC machine, so you have to manually change tools, and it'll stop, and it'll beep the control telling you to put the other tool in. But on a normal CNC lathe, this would be required because you might index the turret or something. And also with this Haas lathe, you don't have to put any kind of offsets really. You just call the tool up and run it. Kind of like a milling machine in a certain way, except that you don't have any G43 offset, which is the height or the length of the tool on the mill. You just call up the tool on this Haas lathe, and the offset's active. And then the G54 is the fixture offset that's being used. Okay, then we wrap it down to the end of the stock, which is 400 thousandths in diameter and 100 thousandths in front of the face of the stock. And then this line, we turn the spindle on. MO3 is turning it on in a clockwise direction, and the G96 is constant surface footage, and the surface footage I set here is 600. This will run this little machine at this diameter at the maximum RPM it can go, which is only 1800 RPM on this little Haas lathe. And so this 600 surface footage, it doesn't mean too much for this program. If you had a big diameter part, it would make a difference. Like at 4 inches in diameter, you're going to be roughly turning 600 RPM with this. But at 400 thousandths, you're going to be turning, the maximum this machine can turn is 1800 RPM. Okay, then we wrap it down to Z0. And then we're going to do a facing cut. So we got to go to a minus 16 thousandths because the tip radius of this particular insert is 8 thousandths of an inch. So if we want to get down to the center with the tip radius, we have to go minus double the tip radius because it's diameter. Remember, on the X on a lathe, to get to this, to get the cutting tool actually to the center of the stock, because of the tip radius of the tool, and we're feeding it 2 thousandths of an inch per revolution. Then we're going to wrap it out in front of the part 100 thousandths, and we're going to come back to X 400 thousandths in diameter. And then a roughing cycle on a lathe is an OD roughing, or on our ID and OD is a G71. The P number is the first N sequence number, which is this number here that the profile starts with, and the Q number in this would be the last N sequence number that the profile starts with. So that's what the P and the Q stand for in a roughing cycle on a lathe. U is the amount of finished stock in X, and this is a radial dimension, not a diameter. And W is the amount of finished stock in Z. And then D is the in this case the depth of cut. I'm doing a very shallow depth of cut here because the insert is got a real sharp point on it. So the depth of cut is 10 thousandths of an inch in this case, and we're feeding it 5 thousandths of an inch per revolution. Okay, so the first line in our what you might call roughing cycle here is to move to X 1/4 of an inch and Z 50 thousandths. Now, certain lathes, if the movement we're making here is going down in X and up in X and down in X and up in X, and on the Haas lathe, it'll give you an alarm if you try to do a roughing cycle that doesn't move continually out in X unless you make this very first move on your roughing cycle move in both the axes. That's why I'm moving in X and Z here. If you just move down in X, say to something like 190 thousandths like on this next line, and try to run this cycle, it'll give you an alarm on this machine. You have to, and I don't really know why that is. Some machines do it and some don't, but this particular Haas control, if you want to go up and down in X like this cycle is doing, because we're cutting the OD of the thread and then we're going plunging back down to do the thread relief all in this one roughing cycle, it'll actually give you an alarm if you don't do two axes of movement. That's why this X and Z to move. Remember, right now it's at 100 thousandths and 400 thousandths in X and 100 thousandths in Z, and it's going to move to 50 thousandths in Z and 1/4 of an inch, or 0.25 in X. Okay, that's just a rapid move to get down close to wherever we're going to start cutting. And this is where it's going to start cutting. The actual movement of the machine is going to be a G01 is a linear move at a feed rate. Now in this case, our feed rate is over here, so we don't have to put a feed rate on this line. Otherwise, normally if you're just doing a, like turning down a line or milling down a line on a CNC machine, and if you put a G01 in the program and it doesn't have a feed rate here, it'll give an alarm, or it would use the last active feed rate in the program if you had one higher up in the program. But in this case, we given it the feed rate in the roughing cycle. And we'll also use this same profile down here on the G70 line, but we're giving it a new feed rate of 0.02 of an inch on that line. So this, typically you wouldn't do this in a program. It might give you an alarm, but in this case it won't, because you've already specified a feed rate in the roughing cycle. So we're moving to X 0.19 inches in diameter and Z0, and we're applying tip compensation on the tip of the tool on the right hand side. That's what a G42 is, tip or cutter comp to the right. G41 would be to the left, G42 would be to the right. Okay, then we're moving up to the OD of the quarter 20 thread, in this case to quarter of an inch and minus 30 thousandths. That's putting a chamfer, a 30 thousandths chamfer on the front of the thread. Then it's going back to Z 0.138 minus 0.138, straight back to turn the OD of the thread. Then we're coming down. This is the angle down the front of the thread relief, and it's coming down to this 0.1875 in diameter, and this this Z here of 0.163, and then we're going to Z minus 0.205. And you know, if you go back and refer to the drawing, you'll actually see these dimensions on the drawing. That's what the beauty of programming with a tip comp or cutter comp on a mill is that you can program the actual shape of the part, and the machine itself will compensate for the tip radius of the tool. Okay, so we went to minus 205, then we're coming back out to 240 thousandths, and then we're putting a little corner break radius here. G03 is a counterclockwise arc move right here, and we're going to X 0.25. We're going to Z minus 0.21, which is 5 thousandths more in depth than this 205. And so because this is a 90-degree corner, that we only have to give it a K, which is the value of the from the start of the radius to the center of the arc. If this wasn't a 90-degree corner and we were making an arc on some angle, we would need an I and a K value here. The I being the distance from the start of the arc to in the x-axis, and the K being the start from the start of the arc to the center of the arc in the z-axis. These are always what they call incremental distances, which means from start to the end in an incremental way, regardless of the work coordinate of the machine or anything. It doesn't have anything to do with where the work coordinate is set. This is incrementally from the start of the arc to the center of the arc. All I, J, and K values in arcs are that way. On a milling machine, you might use an I and a J for X and Y, so it's I, J, K, X, Y, Z. Okay, for these values. And then you always have to, if you have a linear move after an arc, you always have to have a G01 or you'll get an alarm. So you got a G01 here, and we're moving down the quarter-inch diameter, which is here, to minus 385 thousandths. Then we're coming out to 365 thousandths in X, straight out. And then we have another arc here, which is just another corner break. It's a G03, and it's going to X 0.375, which is the OD of this stock, actually. And it's going down to Z of 0.390 with a K of minus 0.005. So the 390 thousandths is 5 thousandths greater than this, and the X 375 is 10 thousandths greater than this 0.365, because remember we're working on diameter here, so you have to double it for the diameter. And the K again is minus 5 thousandths, just like this one was up here. Okay, then we got a linear move, so we got to have a G01 after the arc, and we're going back to minus 600 thousandths in Z. Okay, and then we're coming back out to 450 thousandths. This is going to be the end of our roughing cycle. See, the N11 here corresponds to the Q11 here, just like the P10 here corresponds to the N10 here. This in the roughing cycle is specifying the N sequence numbers of the profile that the roughing cycle is, which is these numbers. Okay, then we got a GOO move is a rapid move in any G-code program, and we're canceling tip comp here, which we've applied it up here. We're canceling it here, because if you do a roughing cycle or a profile or anything basically, and you don't cancel tip comp, you could get an alarm. And we're coming out to Z.1 in front of the part. Now that's the roughing cycle, and remember it was leaving 5 thousandths in X and 2 thousandths in Z for our finished stock allowance. So then we gotta run a finish cut over that, and in a lathe on a G70, when you specify G70 with a P and a Q, it will look up back in the program for this N sequence numbers which correspond to the P and the Q number, and it'll run that profile all over again, but it won't leave the finished stock allowance that you put in the roughing cycle. So this would be P and Q we specified here, and we're going to change the feed rate from the 5 thousandths of an inch to the 2 thousandths of an inch here. Okay, then we're going to again wrap it out in front of the part after our N11 line. We got to do the same thing we did here. We wrap it out in front of the part, cancel tip comp, and come 100 thousandths in front of the part. We turn the spindle off. An MO5 is the spindle off command. And then if I had coolant running in this program, I'd probably put an MO9 here, which is a coolant off. So up at the top of this tool, when it came down to the part here somewhere, I might put a maybe after this line here, I might put an up here after. I'd probably put it right here. I'd probably type in an MO9 right here. That would be, MO8 will be turning the coolant on if I was to do this in this program. I wasn't running coolant here because I didn't want it to splash all over the camera and be hard to, you couldn't film it or record it very easy on video because coolant's going all over the place. So normally right here, right after this MO5, you could put it on MO09 like that. You can't, on this control, you can't put two M codes on one line without getting an alarm. Some controls, like the Mesotrol control, you can do that, but on this control, the Haas emulates a Fanuc control or a Yasnak control, and with two M codes on one line, it gives you an alarm. So you have to put them on separate like this. You'd put M09 right here, or you could even type it in an M9. The control reads it the same way. M09, it's the traditional code, but it'll read an M9 or an M5, the same thing. Then we're going to wrap it out to 6 inches in X and 8 inches in Z, and we got here MO1 is an optional stop. So if we have the optional stop key depressed on the control panel, it'll stop right here. Anywhere you put an MO1 in the program, it'll stop if you have the optional stop button enabled on the key on the control. It's nice if you're, if you want it stopped before tool changes. On this machine, it really, is sort of redundant because it's going to automatically stop at this next line because you got to manually change the tool. So it really doesn't matter. You don't have to have it here, except it'll come up to this T4 M6 line and it'll start beeping continuously, you know, until you change the tool and push cycle start. So it's kind of nice if you don't want it to sit there and beep at you forever while you're checking a dimension or something like that. You can put the MO1 in there. Okay, and this is the this is the threading tool in this case. So we're going to change the tool 4. That's an M6 to tool change, and we're going to wrap it down a 400 thousandths in X and quarter inch or 0.25 in Z in front of the part. Then we're going to turn the spindle on. Now this is a G97. That's a constant speed. So if you program G97 and whatever spindle speed you program here, it's going to try to turn it. This machine can only turn 1800 RPM, so it can turn 1500 here without a problem. If I input like 3000 RPM here, it would just turn maximum RPM, and that's all it could do in this case. But anyway, I'm going to thread this quarter 20 thread in this case at 1500 RPM, and this is the direction it turns the spindle on in the normal or counterclockwise direction if you're facing the spindle. M24 on the Haas control here turns off thread chamfering at the end of the thread. Because we're threading into a thread relief, we don't need to chamfer. If you had no thread relief, you might want to leave this out, and then there's parameters in the control that control the angle of the chamfer. But I don't want it in this case because we want to come right into the thread relief and then pull the tool out so we get the maximum thread. We don't have a imperfect thread on the last thread. Okay, G76 is a threading cycle on the lathe, and this is the X dimension where the target X dimension we're going toward, which is 0.1875 for the quarter 20 thread, and we're going back 220 thousandths in Z, and the depth of the first pass is 10 thousandths of an inch, and then it calculates the depth of the subsequent passes until it gets to the 187.5, and the K value is the height of the thread, that on a radial value, not the diameter but the radius height of the thread. And a quarter 20 thread is approximately this value here in conjunction with this first pass value. You can juggle these around to control the number of passes you get in the thread if you want to try to do that, but you don't want this D to be too big because you could break the insert on the very first pass. So that's the numbers I just chose right off, and it seemed to work all right, and I left them be. The feed rate is on a threading cycle is the pitch of the thread. So on a 20 pitch thread, 20 threads per inch, it's going to be 50 thousandths of an inch. Okay, so it rapids down to this location. Turn the spindle on, and then the spindle's running, and this cycle cuts the whole thread. When it's done, we turn the spindle off, and then we wrap it out to the 6 inches and 8 inches in Z for our tool change, our manual tool change. Optional stop if we have the button enabled on the control panel. It'll stop, and we change to tool number 7 in this case. After that, tool number 7 is a grooving tool just to cut the snap ring groove. So we're going to wrap it down to the same place in front of the part in Z, and we're going to turn on constant surface footage, G96, M3, spindle in the counterclockwise direction, and a speed of 600, which is the constant surface footage, not the spindle speed. In this case, it'll run wide open at 1800 RPM. Because the part is so small in diameter, it can't even reach the surface footage of 600 in this machine at a 400 thousandths diameter. Then we're going to go back minus 0.255. That's the dimension from the end of the part back to the back end of the groove, which would be the front of the tool in this case. And then we're going to wrap it down close to the part. The part's 1/4 inch in diameter right here, so we're going to wrap it down here, which is 280 thousandths, which is 15 thousandths on the radius above the part. I'm going to feed. The G01 is the feed move, remember? And we're going to feed to this dimension in X at a feed of 1 thousandths per revolution. Then we're going to, this is a dwell. G04 on any machine is a dwell, and some machines vary on this command of how long. Some you give it an X number, and some you give it a, X letter, and some you give it a P. This particular machine requires a P for its dwell command, and this 1 point refers to seconds. 1.00 is 1 second. Then it's going to wrap it back out to 400 thousandths, Z.1, turn the spindle off, M05, and then wrap it out to 6 inches and 8 inches, and then we call the M30, which is a rewind the program command. End of program. This command goes back to the paper tape days when you needed to rewind the tape, and the M30 would actually tell the tape reader at this point to rewind the tape. But nowadays you don't use tape readers anymore, so this M30 resets the program all the way up to the head of the program right here. So that's the program on the control. I just want to explain these little commands. This is a very simple program. I've typed it in manually on the control itself, so I had to save it from the control to the computer so I could show it here. So that's it now, and then we'll show a graphics display here that I videoed off the computer, off the machine's control, in a second here. Okay, this is the graphics on the Haas control. It's already showing the part. We're going to restart it. Notice I have optional stop enabled, and it shows the program lines here and the distance from the work offset here on these little boxes here. So I push cycle start. It's going to start with the roughing tool. It comes in, does the face cut, then it starts the roughing cycle down the OD at the small 10 thousandths cut depth because of this sharp tip radius on that insert. And then it comes back. Now it's going to now see optional stops enabled, so it's stopped on the M01 here, so I can push cycle start. And this is the threading cycle. So those are the threading passes. Notice how it reduces the depth of cut as it comes in. There's a calculation in the control for that. And then here comes the groove. And that's it, and the program's done. It's rewound to the top of the program here. So that's the graphics. The graphics on the Haas is pretty simple. Doesn't show any solid models or anything like the newer machines do on this machine. So that's it. This is the lathe operation. I'm pulling the stock out 7/8 of an inch from the collet, just so I'll have enough stock to part the part off when it's done. Tool number 1 is just being used here just to set the Z0 of the G54 offset. Because the tool is set at 0 in the offset page, it can be used to set 0 for G54. You switch to the first turning tool in the program, and this tool is, like you saw in the graphics, it's going to face the part first, then it's going to start the roughing cycle. This air cut could have been eliminated by increasing the depth of cut, but I didn't want too deep a cut because I was going in there and roughing that thread relief. It's kind of hard on this fine of a tool to go in there and plunge into the stock, so I wanted to shallow dip the cut. So it's roughing the OD down here. And it's going to come in and rough the chamfer on the front of the part after it gets down to approximately 1/4 of an inch in diameter. Right there it's roughing the chamfer. It's going to come in and rough the thread relief and take a finish cut, a rough finish cut over the OD. And then come back, and here's where it was running that G70 line in the program, doing the finish cut. After this tool's done, it's going to come back and do a manual, because this machine has to have manual tool changes, of course. It's going to do a manual tool change to the threading tool right here. I'm putting a little oil on the part just so we don't have coolant. You wouldn't be able to see anything with coolant running. You'll notice, you may have noticed in the graphics, the threading tool actually going beyond the thread groove, the leaf groove, but it's because of the nature of these lay-down inserts. You actually have to feed beyond in order to get the thread all the way back in the groove. We come in with the grooving tool. This grooving tool is already the right width, so all I have to do is plunge into the finished depth of the bottom of the groove, and that's it. Now I came in with the parting tool. I did a manual parting operation, and I just set it roughly with the calipers to leave a little stock for the milling. But I should have actually programmed this, because I could have cut the chamfer on the top of the tool, on the top of the screw with this tool, but I didn't think of it at the time, so I just parted them off manually. And I caught them in this little tube thing, because the parts are too hot to touch with no coolant running on the parting tool. So that's it. That's the completion of the lathe operation. And on the next video, we're going to do the milling operation and what's involved with that. This video ended up kind of longer than I wanted, but I wanted to show all those things. So if you watched it to the end, thanks for watching it, and we'll see you on the next one for the milling.